Well, welcome back, dear friends, to Class 8 in this 12-part series as we learn the Dart programming language. In this class, we cover the very important section on classes. This is vital. This, along with functions and along with collections like lists, are the three areas that you should spend the most time on, hence we'll spend the most time on them. In this class, we'll cover classes, inheritance, mixins, interfaces, abstract methods and classes, class variables, and methods. Let's dive right in. What are classes? Dart is an object-oriented programming language. This means it's organized around objects as opposed to actions. It's focused on data rather than logic. In object-oriented programming, classes are a mechanism to create objects. You can think of it as a template or a blueprint to be used to create something we will use in our code. A class defines the form or the structure, which gets at what it is, and the behavior, which gets at what it can do, of an object. The objects get instantiated or created from a class. To use an analogy to drive this home, if I have a blueprint to create a model car, that blueprint would be the class. Each model car that gets created from the blueprint would be an instance, a separate object that is built from the class's specifications of that class. In fact, in Dart, every object is an instance of a class, and all classes descend from the object class. This is the base class for all Dart objects. It is the root of the Dart class hierarchy. So every other Dart class is a subclass of object. Dart does not require all code to be defined inside a class. As you may have already guessed, as we've covered a lot of ground and haven't defined one class yet together. We can have top-level variables, constants, functions, like any procedural language for Dart. When it comes to classes, programming languages start to have a language unto themselves. We will define the terms and do everything we can to make them all relatable. An understanding of classes is critical to your success in programming, especially if you want to move on to the Flutter framework for creating mobile applications. Okay, and here we define our very first Dart class, and we cover some key class terms. So I'm going to start down here where we define a class called dog. Class is a keyword. It's used to create or declare a class. Dog is the name we have assigned or chosen for our class. A field, what a class has, you can think of it that way, is any variable declared in a class. They describe data pertaining to the class. The dog object has fur. Here we have a method. You'll notice it just looks exactly like a function, because it is. It's what a class does. A function in Dart is a function. Unless it's in a class, then it's called a method. A dog can bark. So now we have instantiation. So up here in our main function, of course we still need that. That's a requirement of the Dart programming language. Fido now becomes an instance of our dog class. Note how we use the new keyword and the name of our class before our instance name. So where you would expect to see string or int, now we use dog, the actual name of the class. The new keyword is responsible for what we call instantiation. This, when we do new dog, Fido is a instance of the dog class. This invokes a constructor. Whether it's explicit or default, that's what that does. Once we create an instance, we're now able to use any of the class's members. So over here we have fur and bark. These are known as members. We use them through what's known as dot notation. Members are any of the components that we defined in the class, like fields or methods. So we can do Fido.bark or Fido.fur. So when we print it out, it prints out woof woof. Why? Because that's what's in the body of the method, bark. And true, because that's a bool. This field is a bool, fur is a bool. And when we print that, it prints out true because that's what it's set to. What is a constructor? A constructor is a special purpose function that is part of a class whose role it is to instantiate the variables in a class. If there is no defined constructor in a class, Dart will use the default constructor. When you define a constructor in Dart, use the same name as the class it's defined in. Constructors can have parameters, and they do not have a return type. Here we have a constructor example. So again, we have our class dog and the constructor right here. Dog, bool, fur, print fur. So the constructor always has the same name as the class, has one parameter called fur, which is a bool, has a body that prints the value of the parameter fur that the instances pass in. We also now have a second method called eat. So now we know this dog can bark, this dog can eat, and in the body of eat, it prints something out. I eat half a cup 2 times a day. All right, we also now have a second instance. We had instance Fido, now we have instance Fefe. This instance doesn't bark, but it does eat. See how it makes use of the eat function, fefe.eat, while Fido makes use of the bark function, fido.bark. There's something known as named constructors. What are they and why do we have them? They are constructors that have an identifier, a name that follows a dot. We have them so that we can have multiple constructors associated with one class. This is done for flexibility and convenience. For instance, if for some instance you want to omit a given parameter for a given purpose, you can use a separate named constructor. Maybe one constructor would be used to connect to a database, get data, update a table, and the other to read data from a file and update a table. So here we have dog.hairless and one parameter of type bool called no fur that prints out I have no fur. Using string interpolation, it makes use of that parameter. This statement here is a named constructor. So we have 2 instances. We have the Fido instance that uses the nameless constructor, and then we have a second constructor that makes use of our named constructor, dog.hairless. Now we introduce you to instance variables, more members of the class. So inside the class, I define int weight and int age. They're known as instance variables. All uninitialized instance variables have a value of null. All instance variables generate an implicit getter method. Non-final instance variables also generate an implicit setter method. All that means is, as long as I don't define them using the final keyword, remember how we did that in a past class, I'm using int here. That means I can also set them. So up here, let's take a look at what we do with these. We are setting values for the 2 instance variables. So that, hence the setter method, the implicit setter. So we have an instance called Fido. We have fido.bark. Then we also have fido.weight. Now we're making use of one of the 2 instance variables and we're setting it to 65. And then we can get the result. Fido.weight, when we print it out, we'll print out 65. Here on our second named constructor, dog.hairless, we are using the other instance variable age. And then fefe.age, our other instance variable, equals 14. We print it out, it will print out 14. You will also no doubt run into the this keyword. Other languages have the this keyword as well, like JavaScript. The this keyword refers to the current instance. We have classes, we have instances. This refers to the current instance. If the parameter name and the name of the class field's variable are the same, we then would use the this keyword to distinguish between the 2 and keep things clear. The class's field would get the this keyword prefix. So let's look at this. So okay, we have our nameless constructor dog and we have a second named constructor shelter dog. Here we make use of the age instance variable that's defined up here. We also are passing a variable called age here. So this age equals this age. So now when we print this out, the shelter dog age is, and we use string interpolation, this will grab whatever is passed to it through instantiation. In this case, it'll be 17. Now there is an easier way to use the this keyword, and a better way. It results in shorter syntax, but the output is the same. So here's what we have been using down here. Dog.shelterDog, int age, this.age equals age, and then we print out that variable age through string interpolation. This is the preferred way. Dog.shelterDog, this.age, and then we simply just print that out. So same result. Look how much code we save. Use this way. Now I mentioned getters and setters before when we were dealing with instance variables, but let's go into them formally. Getters and setters are special methods that provide read and write access to an object's properties. Getters are functions that retrieve the value of object properties. If no return type is specified, the type is dynamic. We've seen that before. It's implemented by using the get keyword. Setters are functions that set the value of objects' properties, implemented by using the set keyword. So here we have our favorite dog class, and we are defining a getter right here. Here we get result from an equation that makes use of the parameters that are passed in. Note, result is not an instance variable, nor is it a constructor argument. Similarly, we also set a dog breed member by passing a value to our breed instance variable. So up here, we print Susie Q's result is SusieQ.result.round. So in Susie Q, we're passing in the weight, the height, and the age. So the result will be the weight divided by height plus the age. So that's our getter. We're making use of our getter result. Here, we are making use of our setter. So SusieQ.dogBreed equals chi. So we're setting that string value to chi. All right, let's make this come alive a little bit. We are going to create an application where we do some conversions. We're going to do two different types of conversions, a pint to a gallon and a quart to a gallon. So here is our class called measurements. We have two different constructors. One is for converting pints to gallons, and the other, measurements.quart, is for converting quarts to gallons. So then I have two different getter functions, one for each of our conversions. Down here, I instantiate 4 times, so I have 4 instances. The first 3 use the first constructor to convert from pint to gallon. The bottom one uses our second named constructor, measurements.quart, to convert from quart to gallon. So you see here, as we use each of these instances, we get to pass our value in as an argument to correspond to each parameter. Measurements milk equals measurements 2. So I'm asking to understand how many gallons there are in 2 pints. And when I print that out, the result is 0.25, so a quarter of a gallon. Same thing here for soda, measurements 4, and that's half a gallon. And finally, for 8 pints for measurements water, that results in an even gallon. Now I do the same with iced tea. Measurements.quart this time, different constructor. I pass in the value 5.5 and I print that out. Iced tea.gallon2, our second getter, and the result is 1.375 gallons equals 5.5 quarts. Now we're going to get into a topic known as inheritance. Inheritance allows one class to be created from another. This creates a parent-child relationship. The class you are creating from is the parent class, the one being newly created, the child. To inherit from one class to another, we use the extends keyword in Dart. Child classes inherit all properties and methods from the parent except constructors. In Dart, a class may only extend or be a subclass to one class. So the syntax would look like this. Class, child class, extends parent class. So now child class is a subclass of parent class. All right, so let's look at an example. We have two classes here. We have the instrument class and we have the guitar class. Guitar extends instrument. So guitar is a subclass to the parent class instrument. In the main function, we create an instance of guitar. Guitar, G1 equals new guitar. But we are able to access the plays method from the parent class instrument. So when we print out G1, our instance of guitar, the child, dot plays, a method from the parent, we pass in the argument strums, we're able to execute that code. Did you know in Dart we can have multiple levels of inheritance? So what does that mean? That means this whole inheritance business can become quite hierarchical. So here we have our class instrument, and we have a class guitar, which extends instrument. And then we have another class, guitar type, which extends guitar. So as a result, the guitar type class instances will have access to the same plays method that is in the instrument class. So here we have our instances, guitar G1 equals new guitar, G1.plays strums. So we've seen that on the previous slide. All that is G1, the instance of guitar, has access to the methods in its parent instrument. Now we have guitar type G2 equals new guitar type. So now we're working off the guitar type class. We have an instance of that called G2. G2 also has access to plays, its parent's parent. So there are many possibilities, and we can be as flexible as possible while really continuing to encapsulate our code in very smart ways that make sense to make it easier to maintain. We can use something known as overriding the parent method. This allows us to redefine the method in the child or subclass. We use the @override annotation to indicate that we are intentionally overriding a member. Again, a member is a variable, a field, or a method. So here we have class instrument and we have class guitar that extends instrument. So far, nothing different. But the next line, line 20, we override the plays method from the parent class instrument by placing the @override annotation just before it on the line before that method. This all happens in the child class. Notice here I don't need to use the super keyword to make this happen. So when I go up to my instances, guitar G1 equals new guitar, print G1.plays with the argument of strums. So what's different? Here, though, it outputs the guitar, strums, and it sounds beautiful. Why is that? Because I overrode this method in the child class guitar, and I have an if statement. If plays type equals strums, which is what I'm passing in as an argument, then return the guitar, string interpolation, take whatever I'm passing in, plays type, which is strums, and it sounds then super.sound. And sound is from what? The parent class, and it's set to beautiful. So I get the guitar, strums, and it sounds beautiful. Do you see how I use members from various different classes here? And it's all perfectly permissible. Let's take a look at the enumerated type. So enumerated types, often called enumerations or enums, are a special kind of class used to represent a fixed number of constant values. This has the same effect as a class decoration. They have the following limits. You can't subclass, mixin, or implement an enum. You can't explicitly instantiate an enum. So let's take a look. Here we have our main function. The very last line of code here is our enum. We call it special. And inside we have several members. We have kindness, compassion, love, mercy, empathy. Kind of a nice list, especially for right now. If we print special, the first line of code within the body of our main function, we will get just the word special, the name of our enum. If we print special.values, we will get a list of each value preceded by special and dot. We can create a list of type special, call it qualities, and let that equal to special.values. Then we can elicit each one by their position. Zero base, so quality 0 would bring us back special.kindness. It's the first one in the list. We can employ a for loop, a for in, for var x in qualities print x, and that would one at a time print special.kindness, special.compassion, special.love, etc. So enums represent a fixed number of constant values. Let's talk about mixins. A lot of programming languages have something called mixins, or that function like mixins. Mixins provide a way of reusing a class's code in multiple hierarchies. It's useful in Dart in particular because Dart will only allow us to have one superclass. We covered that already. To use a mixin, we use the word with. When would you use them? Well, when we need to share behavior amongst classes that don't necessarily share the same hierarchy. In other words, a sub of a super or a sub of a sub of a super, that type of thing. So they're not in the same line, that hierarchical relationship. Here is something important to remember about mixins. The mixin class is implemented in between or mixed in between. You can think of it that way. The subclass, so the one that is using the mixin, and the superclass, the one that's being extended by the subclass. This is important for name resolutions, so we are clear on how potential naming conflicts will be resolved. In other words, if we're using class members with the very same name, where are we getting our values from, which is the actual object that we're going to use. So I have a little depiction for you here. On the top is superclass, in the middle is the mixin class, and on the bottom is the subclass. So we use extend, as we've learned, to inherit from the superclass. So sub uses extend to the superclass. Now super becomes a superclass of our sub. We use with to make use of the functionality in our mixin class. Let's dive into a mixin example. Hopefully this drives it home. So let's start with class employee. This is our superclass. 3 instance variables, name, business, and department. It has one method, who am I? It makes use of the 3 instance variables, name, business, department, and it returns a string using string interpolation, making use of each of those 3 variables. Then I have subclass number 1 called programmer. It extends superclass employee, and it uses mixin full-time, making use of the with keyword. Then I have a second subclass, HR, extends employee, and it makes use of the part-time mixin. So let's look at the mixins. The first thing you notice is it is defined using the mixin keyword. Mixin full-time has a method called full, and it returns a string. I work full-time. And then mixin number 2 is mixin part-time, and it has a string called part, and it returns I work part-time. So now we go to our callers. Caller number 1 for John. John is a programmer. We create an instance of John by instantiating the programmer subclass. And then John makes use of the who am I method from the parent employee, and he passes John, ABC Corp for the business parameter, and then DevOps for the department. Then we have Sheila. Sheila is an instance of the HR subclass. Sheila also makes use of the who am I method from the parent, and her 3 arguments are Sheila, HQ people, and HR. So notice both John and Sheila are making use of the methods from their respective mixins. John's able to use the full method, which returns I work full-time. Sheila is able to do the same with the part method defined in the part-time mixin, which returns I work part-time. Now here's an example that proves out what we said about mixins being in between the sub and the super with name resolution in action. So we have class employee. Class employee has an instance variable called foo set to employee. Mixin full-time has a variable called foo set to full-time. Now, instance John, and John again is an instance of the programmer class, makes use of john.foo, and you'll note when that gets printed out, the value for that is full-time. So it becomes very clear that when name resolution is an issue, the mixin will come before the superclass. Had there not been foo in the mixin, then John would have certainly used employee as a value. I'm going to expose you to yet another way to use the members or the functionality from other classes. Let's talk about interfaces and implementing. Interfaces are useful when you want to use the functionality from a given class without inheriting it. In these cases, you would implement the class instead of extending it, and that creates the interface. So here we have class planets and we have class my class. My class implements the planets class. There's some quirky things with interfaces. If you don't define its members, name, and planet message from the class that you are implementing, you'll get an error. So when we implement a class, it forces us to define all of its members. Note here that mixins don't have that same requirement. So when we go ahead and instantiate P1 from my class, P1.name is Jupiter because we set it right above on the line above. P1.planet message, we use P1.name, and that prints out this is planet Jupiter. And this is fairly useless, right? Because these are exactly the same methods in the my class and the planets. A couple of things to point out here, and we're going to compare and contrast all these different ways of using class members and functionality real soon. I can add all I want to the string. Instead of saying this is planet Jupiter, I can say this is my planet Jupiter. What I can't do is I can't override this method in my class. I can't add a second variable to planet message. If you do, you'll get an error something like has more required arguments than those of overridden method planets.planet message. It's one of the limitations when we use interfaces. All right, I created this depiction just for you and me. So you may be now saying to yourself, I have so many ways to make use of the functionality and the members from one class to another. What are the differences? So let's go through this. First, we learned about inheriting. To inherit one class from another, we use the extend keyword. It enables sharing behavior between classes. Think we are making use of or building upon something from the superclass. It doesn't force me to define its members in the subclass. There is a natural parent-child relationship from superclass to subclass. Each class may only inherit from one and only one superclass. Now let's take interfaces, which is the next one moving to the right. That's what we just covered. The keyword used here is implement. Provides access to the public members of the implemented class without the need to implement anything. Think of an API. So we have access to other functionality. Defines how we interact with the members. Dictates their definition in the implementing class. Cannot share features or behaviors with an interface, and you can implement multiple interfaces. Finally, the mixin. The keyword we use here is with. It's not in the class hierarchy. That is, there's no superclass, subclass, parent-child relationship required. Does not impose usage restrictions nor forces type restrictions. Does not force me to define its members in the class using the mixin. Can implement multiple mixins. Usually we put common functions inside a mixin, and it helps in lieu of the fact that Dart does not permit multiple inheritance. Now you're a curious person, so you're probably asking yourself, can I use extend, implement, and mixins to one class? You bet you can. Let's see what we have here. We have class foo, we have class foo2, we have class foo1, and we have mixin foo3. That's a lot of class stuff. So class foo1 extends foo, uses foo3 as a mixin, and uses foo2 as an interface. Note here that we must use our mixin before our implementation. So that's why foo3 comes before foo2. So we have string 1 in class foo1, which is the same method that we have in foo, our parent, our superclass of foo1. Then string 2 is from foo2, and we must, is not the case with string 1 from foo, but from foo2, since it's an interface, we have to define that here in foo1, the class that implements it. And finally, we have our mixin, And inside of Mixin, we have a mix method, and it returns I'm the Mixin. So we instantiate this as instance 1 from foo1, from the class that's doing all this borrowing, begging, and stealing. And we are able to print out all the print statements. First from the Mixin, I'm the Mixin. Then from the parent class, I am from foo, who is inherited. And finally from our interface, I'm from foo2, and I'm being implemented. Okay, and let's talk about abstract methods and classes. I promise there's not too much more. I know this class has been super long, but I wanted it in all one tidy unit. Abstract classes are ones that cannot be instantiated. They are useful for defining interface. They often have an abstract method. They can only be extended and not implemented. They can't be instantiated. In other words, you can't create a new object or instance from the abstract class, but they can be subclassed. We use the word abstract to create one. A subclass of an abstract class must implement all abstract methods or be declared an abstract class itself. Abstract methods can only exist within an abstract class. To define the abstract method, we place a semicolon after the opening and closing brackets like this. Void abs method, open paren, close paren, and then semicolon. Notice we don't have a body. You can also create regular methods, sometimes called concrete methods, in abstract classes. When would you use the abstract class? When you want a bare bones skeleton from which to implement. When you need to use abstract methods, the abstract methods can only exist in the abstract class. And when you want fake or placeholder data, perhaps, when you're building your code. Let's compare the abstract class and regular interfaces. Abstract must implement all abstract methods, cannot be instantiated, can use abstract methods, uses the abstract keyword to define it, can only extend one abstract method. Interfaces must implement all members, can be instantiated, cannot use abstract methods, uses the implement keyword to define a given class, and can implement multiple interfaces. Okay, let's check out abstract classes and methods in action. So right up here, we have an abstract class called holiday. Inside, we have two abstract methods, one called book car, one called book hotel. Neither one has a body. Then we have a concrete function or a regular function called book cruise. Remember, that's perfectly permissible, and it returns a string. Then we have two inheriting classes. Class beach extends holiday, and class mountains extends holiday. In class beach, we have the book car method, and we have a body there where we print book the car. Same with book hotel, book the hotel facing the beach. In the body of mountains, we again have to define book car, and we book the car to drive to the mountains, and book the hotel in the middle of the woods by the lake. So then our callers in our main function, h1 is instantiated from beach, h1.bookcar, and that prints out book the car, and h1.bookcruise prints great, you booked a cruise, enjoy. And then h2 is instantiated from the mountains class, and that prints out book hotel, book car, respectively, and it says book the hotel in the middle of the woods by the lake, and book the car to drive to the mountains. Works exactly as expected. And we'll round off this wonderful class with a dive into class variables and class methods. So we use the static keyword to implement class-wide variables and methods. Static members retain their values until the program finishes executing. They are referenced by the class name, not the instance name, the class name, as would make sense, right? Static variables, aka class variables, are used for class-wide state and constants. And again, state is data. Static variables aren't initialized until they're used. So when would we use instance variables and when would we use class variables? Instance variables should be used when each instance will have a different object like a name or an age or what have you. Class variables should be used when the value of the variable is independent of the object, will not be a unique object. So now let's take a look at defining a class variable. So we have a class Mercy. Here we have a class variable using the static keyword, so static const, because it's not going to change, personality type equals loving. I should point out, Dart prefers lower camel case for constant names. So that means we start personality with a lowercase and that second word type, uppercase T. And then we have a regular old instance variable that we've been using right along, var foo equals foo. Now we have our instances. So void main, we print mercy.personality type. Remember, they're referenced by their class name. So personality type is a class variable prefaced by the name of the class. Mercy.personality type equals loving. So that should come out to be true, and it is. We can't do this. We can't reference foo by the class name mercy. That won't work because it's not a class variable, it's an instance variable. So we must still create an instance, mercy, word equals mercy. So now word is our instance of mercy, and we can use foo, word.foo. And here on this final slide, I tried to make it the very best of the whole class. We'll use much of the knowledge we've gained so far in our Dart lessons. We'll use classes, methods, class methods and variables, libraries, callers, the main function, comments, and printing. Hopefully it comes all together here. Here we create a calories burned applications using a static method and two static variables. So class or static methods belong to a class rather than the instance, just like the static variable. Class methods do not operate on an instance and don't have access to this keyword. Use static methods when the code in the method is not dependent on instance creation and is not using any instance variables. Number one. Number two, the code is to be shared by all the instance methods. Number three, the definition of the method will not be overridden or changed. Okay, so those are the three conditions under which you should use static methods. So let's look at this. We have a class calories burned. Num1 is the value that will not change used in the equation to multiply the weight by. Num2 is a second static number we need in the equation that will not change. We use the power method from the Dart math library here. So you see we had to import Dart math. And we create a static method, calories burned walking. So how many calories are we going to burn when we're walking? That will not be changed or overridden at any time. Then we have the caller. The caller uses the static method to determine the calories burned per minute for a person who weighs 90 kilograms, is 1.7 meters tall, and is walking at a pace of 1.4 meters per second. So calories burned, we have to reference the class because this is a class method, dot calories burned walking, and we add in our three requisite doubles here, 90, 1.7, 1.4. And by the way, just because we use 90 as an argument, it will take it in as 90.0. It's a double. And then in our calories burned static method, we have total, where we have num1 times the weight, v to the second power divided by the height, and num2 times the weight. And we come up with the final calculation when we print that. So it doesn't matter what values we put in. If you need a method to determine how many calories are burned when you're walking, we can use this again and again and again and again. My fine friends, thank you for making it all the way to the end. I hope you found this valuable. If you did, do a couple of things. Subscribe to the page, give me a like, leave a comment, and share this with somebody who might need it. We're trying to start a revolution here.